I'll leave okay.
Yeah. So the PDF that Andrew talked about, it's actually here. So I put it in Scalable Data Science, DBC Archives 2017 Parts Advice from Industry. So you can look at this more carefully. There's a lot of interesting points. And I think Andrew's perspective is interesting because you've got, this whole enterprise corner as well, right? Okay, so now what else I wanted to point out there is a directory now called student projects in 2017 parts. And there's a README file here that has instructions for making a pull request. So the basic idea is you have to fork this. So you will have a copy in GitHub. And then once you fork, you have to make an account on GitHub. And then you can, create a directory, whatever you want to call it. And then you have to follow, install Git. So these were done on the meetup we did about Git. So git init, git remote, add -f origin, You have to put your username here. And then git config. This is the sparse checkout. So you don't check out everything to save space in your thing. And then, you have to echo oh shoot, I made a mistake. So this should be a bit longer. It should be 2017 parts, Oh, no, it's correct. 2017 part student projects into your .git info sparse checkout file. That's what this is. Then you just, pull origin master, and then you can cd into this directory. There should be nothing there, and ULS. Then you go to your Databricks Community Edition, and if you have a directory of a bunch of files, notebook files, then you can just go to that directory, or if you have just a one file, you can just export that into the .dbc archive format and dump that single DBC file into this directory. So you can call it whatever, say project file name, .dbc. Please put your names, your last name. If there are two students, put the last names in alphabetic order by last names. And use sort of camel casing. So begin the second last name with uppercase and things like that. Then please push, do the set upstream origin master, and you can check out the status. And if you're kind of sure that you have the right thing, and make sure you periodically pull, then you can do git commit -a to add everything that's there, -m for the message, and you can put some message here. So once you've done this commit and pushed, you've just pushed it to your fork from the local sparse checkout of that directory alone on your laptop. Now finally you have to go to the fork, go to your GitHub repo, and then make a pull request on the browser. This will make a public pull request into this, and I want it to be a public event because I want you guys to man up your own code. And I will around New Year's, because I'm buying a new house downtown and stuff. My wife has me working. I will get back into it and look at the stuff, and then I'll push back. So then you can pull, and we can pull and push. Okay. So I think January 14th-ish is when you guys are all presenting, right? The last week. Okay. That should be that. Now, yeah. So let me. In the interest of time, I may just go through the notebook again. There are steps on all the different libraries you need, but just because slightly running late. So I added all these libraries you will need. Somewhere. Probably here, I believe. So anyway, there's a bunch of libraries we need, and there's a DBC archive, and because I'm currently taking, let me just give you a snapshot of this. So you need TensorFlow == 1.3.0. This is a Python thing. You need keras equal 2.0.8. And what else do you need? You need distributed keras, dist minus keras 0.2.0. And I think you may need H5 pi. I'm not sure yet. And Spark Deep Learning 0.1.0 minus Spark 2.1, I believe. Okay, so there is a full bundle for this. I'm working on it, so you can just upload. But for now, let's just jump into the code and ideas, and you can click later. Yeah, I'm also taking this course on how to supervise PhD students. That happens. Okay, here is TensorFlow. Right, so this is where we were last time, right? We were at 52. This was the solutions. And we basically briefly looked at keras. So now we're going to jump a bit into what's underneath keras. Remember, keras was this high-level thing that was actually talking to TensorFlow downstairs. So now let's get into TensorFlow. So as I said yesterday, TensorFlow is a general math framework for not just deep learning, but it's designed to accommodate easy operations on tensors. There is also nice mappings to highly performant low-level implementations, including native CPU and GPU. There is optimization via various efficient gradient descent variants, especially the ones that operate at the level of every operation. So this is your, backward propagations and things like this. Yeah.
So if we want to work on GPUs,
yeah,
do we need this CUDA library?
Yeah, so I think, well, first of all, the hardware you're running this on should be GPU. For us, it isn't, our little community edition. And honestly, I don't know what TensorFlow is doing under the hood for GPU. I'm assuming it'll be using CUDA. It's the open source. Yeah. But of course, remember, TensorFlow is the open source variant of what Google is really doing in-house. Google has they're like hardware level optimizations, and they're building chips for their particular algorithms and stuff. So of course that's all closed. But it's just to keep in mind. So when you subscribe for these API services from Google, they're kind of doing stuff on their magical customized things, right?
There is this library called PlaidML, so you can use other GPUs than NVIDIA's for a TensorFlow.
Oh, that's cool. PlaidML?
PlaidML. It's recently released, so it doesn't have like RNNs, but I think it has CNNs.
PlaidML?
Yeah.
Dinner plate?
Plaid.
Oh, sorry. P-L-A-D-E?
I.
Oh.
P-L-A-I-D.
PlaidML here. Let's see if this is.
Yeah, top one.
Right. Yeah. Okay. So anyway, this is definitely not my area of expertise, guys. Let's just go to, let's just go to what industry wants people to know, right? Like very quickly. So this is yeah. So this should be our so when you import TensorFlow, so this is just pure Python, right? And I have constants and variables, so I can have tf.constant, and I'm sort of creating a constant with value 100, and the name of this is x, and I'm creating a TensorFlow variable, which is now x, this constant, plus 50, and I'm naming this variable y, and so this should just declare this is how you declare a constant and a variable in TensorFlow. Okay. So yeah, Adam says there's a bit of ceremony here. So So TensorFlow does evaluations lazily. It basically is used to describe a computation graph, specifically a directed acyclic graph of arithmetic operations over tensors. So we basically have to essentially design first and then do the calculation. So here, let's say I'm having something called init node equal tf.global variables initializer. So init node essentially will be a default constructor for a global variable. Now I have this tf.session, right? So this is how I will interact with the TensorFlow session. So with tf.session as session, I can start doing various things in my session, right? So this would be, I'm now running my init node, and then I'm printing the session run of y. So remember, y was now cooked up to be 100 plus 50, so it's 150. So this is how we would actually run things, okay? After we design some set of operations. TensorFlow integrates tightly with NumPy, so you can check out the NumPy cheat sheet if you. So now what are we? So we're going to declare something called data, and I'm simply taking random normals with location parameter 10, it's the mean, and the scale parameter 2, is the standard deviation, yeah, 2, and I'm asking the realizations to be what did I do?
It didn't import.
I didn't import NumPy as NP.
Yeah.
Okay, good. So I haven't played with this import NumPy as NP.
Is
that right?
capital?
No. I mean, my Python, like, I haven't touched Python in a while, so we'll figure it out. Okay, that's right. Okay. So I just have a 3x3 matrix. Good. Now, all nodes get added to default graph. So unless we specify otherwise, so we can reset the default graph so that it's not cluttered up. So here is so we take our TF, TensorFlow reset default graph method, and so it's all reset. And then I'm going to now say x is my constant, and y is my variable, which is x times 10. And then now I'm going to have my initial node to be this global variables initializer, and my TF session as session is going to have I'm going to run the initial node, and I'm simply going to session and run the actual y I made from NumPy. Okay. So it's a little bit of getting used to, because you're kind of designing something and then you're sort of dropping into the session, actually doing things. Okay, so we'll often iterate on a calculation. So here is our tf.session as session, and I can do my standard for loop in Python. So for I in range 3, x is x plus 1, and let me print these x's as they're being changed. Okay, let's see how the structure. You can see you can manipulate x as it's changing. Okay, so we're simply adding 1 everywhere. So now,
sorry,
yeah.
So what's the difference from the ordinary?
There's nothing. I'm just saying you need to put with tf.session as session colon, right? So you have to do things in a TensorFlow session. That's all. It's just one extra layer, right? Because you can just forget about it.
Okay.
I mean, not really, but yeah. I don't know. I mean, let's get your hands dirty, right? And then you will start seeing how to do things, because there is an assignment and solutions and stuff as well. Yeah, so if you didn't have this, it looks like just like Python, right? But here you actually have a TensorFlow session that's running, and you need to interact with it. Has anyone done TensorFlow on any of these MOOCs you have?
Not on MOOCs, but on computer.
Okay, just for layers. Yeah, so yeah, this is kind of interacting with TensorFlow. All right, optimizers, right? So TensorFlow includes a set of built-in algorithms for optimization, and of course, it's such a high level, relatively low level. You can build your own optimization routines eventually. But most of the things we're going to be using will be oriented toward, gradient descent algorithms in a big data context, which means, batches and things like that, right? So it's stochastic gradient descent and its variance. So let's see. So we can use the optimizers to solve anything, and okay. So let's just look at this code. So what are we doing here? I'm literally looking at this after that day in Dublin. So this is, see, no, not even this morning. So anyway, so this is so this is a placeholder. So now you're saying X is actually a variable of type float. Okay. Y is one, also float. Then I have my TensorFlow variable with this list one, and it's a slope coefficient. And I have another one, what its name is the intercept B. Okay, so these are variables, and these are placeholders, which will eventually act as nodes, I believe. Okay, so we have MB. Now we're going to define a model, Y model. So what are we doing? We're using multiplication in TensorFlow. So you have to do the dot multiply. It's a method. So multiplying this placeholder X by this variable M and adding it to variable B. Okay. So that's my model. And my error is df dot square y minus y underscore model, right? So once again, I have some placeholder node y, and I want to know what the difference between what the model predicts and what it is actually here. This is where I'm going to be dumping my data down the road, right? So it's some kind of placeholder. I can place one data at a time, one X row and one Y row at a time. So then I have train op I'm defining. So this is tf.train gradient descent optimizer. So this is going to be my optimization routine. And I believe this should be the stopping rule for the optimization routine. And I'm interested in minimizing this notion of error, right? So it's the squared difference between the prediction and the actual observation. So I'm not sure if this is the learning rate or it's the one that, the stopping rule, like when to stop. Yeah.
What do you minimize? Is it like the individual error?
Yeah, no, so remember error is what we defined here, right? Okay. Error is just the square. So df dot square is the squaring of multiplication by itself, but the itself is y minus y underscore model. So y model is just this straight line, right? It's the equation for the line, right? X times m plus b. M is the slope. X is the. So we're just doing like a linear regression.
Exactly, but then you're trying to have the y model close to y. So
yeah, exactly. Y will be the. Yeah, you got it. Yeah, it's just the squared error. If I took the, if I had lots of them and I averaged them and then took the square root, that's what we've been calling square root mean squared error, right?
Yeah.
And X can be multidimensional again?
Yeah, I believe so eventually. I actually don't know. I have to read the rest of the lines first. But yeah, we'll figure it out. I was there and I think I understood this when I was in Brian's thing. This is also a more detailed version that he sent me. So we'll figure it out. So, okay, now what am I doing? I'm global variables initializer. It's being called from my model. So this is not the y underscore model. This is just model. And then Okay, so now is the game, right? So I have setting up my for loop after I do session.run model. So yes, and yes, so this is going to be okay. So and then what's happening in the for loop? So I have x value is np.random_rand. So I'm initializing the x values from this. So this np.random should be the uniform 0, 1, I think. No. So it's just a bunch of random initializations.
Yeah,
how long is it?
The x value. How many randoms? It's one number. One number?
Yeah.
Just one number.
Yeah. I mean, I can't, yeah, it should be one number, but we can try it if you want.
What is model? What is modeling? What is the global?
Yeah, so let me go through the next 3 lines, and then I'll come back because I can't know what I don't know. So just give me 1 second. Right, because you're asking syntactic questions, and I really sort of okay, right? So I'm just like my Python is like kind of back there. So anyway, so we have an initial x randomly initialized, and then we basically take that randomly initialized x value, multiply it by 2, and add 6. So that's a fixed slope and a fixed intercept, right? Okay, so now, and then, so this is basically how I'm creating my y value, because I'm pretending this is my real known slope and known intercept, right? Just cooking up some. So now I have my x and y values made up for 10 of them. And then what am I doing? Session, run, train, and I'm creating a feed dict. So this is input, so I need a dictionary to feed the data from. And the feed dict has x as a key, y as a key is a Python dictionary, and x value as its value, and y value as its other value. So I'm basically going through this loop and running the session, by feeding these things 10 times, right? So then at the end of this, I have my out declared to be session.run of the list MB, right? And MB is my TensorFlow variables from out here, right? Mm-hmm. So what else? Now we are printing it out, and finally we're printing some string formatted to print the right indices of the out, okay, which should be my learned stuff. So here's my model. So it's predicting my slope is 1.59 and my intercept is 1.98, which is quite close to not quite. I mean, this is okay. This is way off, right? So there's a lot going on. You can't dive into it immediately, but let's just sort of march through downstairs. Okay, so okay, Adam says that's pretty terrible. So let's try 2 experiments, change the number of iterations the optimizer runs, and independently try changing the learning rate, right? So the learning, oh yes, so the 0.001 must be the learning rate. That's how quickly you jump around in your slope, when you. Okay, so that's what. Why don't you guys play with this now? Yeah. So I mean, this is going to be. Yeah, you can increase this and. Oh, true. Sorry. Yeah, you can't. That's actually not a bad thing to figure it out. I thought I have a full Uber jar that you can download, but I think I'm going to let you guys battle out because I told you what you need already. Yeah, it's a good 10 minutes.
Yeah, it's not.
Yeah, this is actually quite cool. So here he's explaining, making connection between what we did in Keras yesterday, right, which was telling TensorFlow what to do. Mm-hmm. So all these details are here actually. So it's calling the, when you do the k dot dot thing, it's actually calling the right TensorFlow backend. And yeah, so here it's, if you look here, it should define dot for TensorFlow. Let's look here to be the R multiply method for TensorFlow. So this is TensorFlow backend of Keras, and let's just search for the dot method. Yeah, so it's using matrix multiply. You see, it's calling TensorFlow's matrix multiply here. And I think there is a switch where it goes between all examples. Yeah, so when you say transpose and Keras,
I guess when you let it run more often.
Yeah. So it's calling the TensorFlow's transpose method.
Because here's the
and so on. So again, yeah, the point is there's no magic here, right? So Cholet is working quite hard on babbling for you, right? Between different packages in the backend. Okay. So yeah, here's more information about what else helps TensorFlow and other frameworks run fast. Well, they take advantage of the various hardwares. The actual TensorFlow is not Python. It's just Python wrapped C++, right? And there's a whole bunch of other stuff that experts in deep learning use. At work, we have in Combeyond, we have some guys who did their masters in AI and things like this, so they just tell us kind of what's going on, right? So you have to work with experts, but that's. Did anyone improve? Oh yeah. So let's try and improve this because you guys may not have the library yet, right? I mean, all the imports yet.
Yeah, you need to change the learning rate to something.
Something smallish.
I'm
gonna try 100 and see what happens if I just.
If you increase it above 10,000,
yeah.
you'll learn this.
Yeah, so this is more important, right? Because it's my data itself. Because I need more data, right? So 100 is a lot to just learn 2 numbers. That's pretty good. And if I do this and I can play around, this is getting better, right? So anyway, back to 10. So I really had a lot more to do today, but let's do just 54 briefly, right? I'll just look at this and we'll continue from here. So this one is essentially getting you familiar now with matrix operations with TensorFlow, because we just saw some scalar operations before. Now we'll just so I'm defining real slope x1, real slope x2, and real intercept 5 to be 2, 3, and 5. And now let's generate a batch of true data with a little Gaussian noise added. So what's going on? I'm defining a function with the parameter called size, whose default value is 10. And please, Python people, correct me if I'm blabbering. Right? I'm just reading like that. And then x is I'm just taking random samples of just size 2, I guess, for x1 and x2. And then y, I'm doing a matrix multiplication of x by this vector, right? These are declared here. So, and then I'm adding the real intercept from here plus 0.2 and multiplying it by normal random numbers of size 10. So what is going on here? Here again, what is y giving me now?
You are multiplying each x value by the slope, the represented slope, and then you add in the intercept multiplied by random number.
Yeah.
For every random size.
So what is the regression interpretation?
To y value to the x or y.
So you have like two independent variables. Independent.
Right.
Just two-factor.
Yeah. So let me just see. Two-factor linear model. That sounds good. Yeah. So I'm basically drawing a bunch of x's and then having two slope terms and one intercept term. And this is basically, am I not just defining a plane? Yeah. Okay, so then, so maybe we should stop, right? Because at least, you've seen me like live read it, right? I'm not, I mean, I really had trouble like getting all the stuff working for Andrew to talk, so I could do this live read, but you can do this yourself, right? You've got enough about it, and we will come back to this and march through this. So next week, I guess we have a very tight schedule because so my plan is to give you guys at least the codes and some fast enough run through it so that especially Mariama might need to understand transfer learning because the project, Well, it will be in YouTube. So. Yeah, so, and these are very, very important minimal sort of scalps you want to wear or whatever, feathers on your hats in deep learning. So we'll try to brush through them a little bit, but I will try and read all of this beforehand. So anyway, and in terms of libraries, I showed you what they are, but I think Tilo and I have to experiment on a different community shard to give everything go in one pack. But because I showed you all the ones you need, it'll be a good idea for you to do it yourself because you need the Python eggs and
You don't. You could just write the name of the library and Python, and Databricks will look it up in the Python.
Yeah, exactly. Yeah, you can do that yourself. Yeah. I think I showed you what all the ones we need, right? You can do. I think it's a good exercise for you to do it.
Tensorflow number 5.
Yeah, I have put it somewhere. I think it's in one of the notebooks, right? So I probably put it in the wrong one, but I listed all the things you need, so you can copy paste it as well. I'll put it in 50. But unfortunately, I have homework for my PhD training course, so I better take that. Oh yeah, here it is. So 50 has all the installations you need, I think. Okay. So do those on your own.
Yeah, for me, Keras didn't work alone. I needed to install NP utils. I don't know why, but Keras had a problem.
Okay.
Another package called np_utils.
Oh, okay, that's good to know. Right. Yeah, so if you have these kind of things, please discuss in Meetup or whatever, like you can sort this out amongst yourselves. And because I can tell you that my library that's currently, I have this TensorFlow, A-list stuff Dimitri put in here. Magellan we don't need. Keras, Esri, Twitter you don't need. Scalable Digest you don't need. Disk Keras. Did you put disk Keras? This we will need later. Distributed Keras. Yeah, H5Pi. Yeah, I don't have anything else, so I'm not sure what you're on about.
Maybe it will include this part, deep learning or something.
Yeah, so yeah, try them all, and then yeah, please email me if it doesn't work after you've tried all of these. Okay, guys, we'll see you next week.